All right, so here's just a short video just explaining the differences between permutations and combinations. That's permutations and combinations. So we'll start with combinations. You've heard this word a lot in just regular, English language. If you have a combination of this and this, right? It's kind of like a mixture, okay? So if you're mixing three things together, let's say in a recipe, it really doesn't matter which order you throw the things into the bowl, okay? So the selection of objects without regard to order, okay? So what we mean by that is that if you have three ingredients that you were making a cake out of or whatever, A, B, and C, and you were to put them in the bowl, and if you were to put them in the bowl maybe in reverse order or a different order, any of these orders, and there are more. Actually, let's just go through and see if we can label them all. So we have A, B, C. We have A, C, B as well. Okay, that's a little different order, right, than the first one. We also have B, A, C, and we have B, C, A. That's a little different order than the second one. We have C, B, A, and we have C, A, B. Okay, and those are all the different rearrangements we could rearrange those three letters. Okay, that's it. But this is all one combination. That's one combination. You have a combination, okay, of three things, A, B, and C. So the order doesn't matter. Order doesn't matter. Okay? Now, over here, permutations, okay, and contrasting, this is an ordered arrangement or sequence. So ordered arrangement means that order does matter. The order does matter. So if we looked at the same set of A, B, and C, even though this is one combination, this is actually also and 6 permutations. Because when we're talking about permutations, order does matter. So guess what? ABC is one permutation, BAC is a second, CBA is a third, and so on. 4, 5, 6. Okay? So when order matters, then you use permutation. When order doesn't matter, you use combinations. Okay? So an example of a combination type question, how many ways can the teacher select 3 students to help him rearrange the desks in the classroom? Okay? So if we were just choosing 3 students, okay, that's my example, then really the order in which I choose these students does not matter, right? So this is definitely combination. Over here, an example would be how many ways can 3 students finish first, second, and third in a race? The 3 students in a race, okay? Race order. So obviously the order does matter because let's say we have Jason and we have Emmanuel and we have Ben, okay? In that order, congratulations, Jason, you got first place. That's definitely different than if Emmanuel wins and Jason comes in second and poor Ben is still third. Sorry, Ben, you get third, all right? Okay, so again, see the order matters. So in that type of question, order would matter. One more thing I'll let you know about is the notation, okay? So here's the notation. If you have 3 and you're taking a combination of 3 items, so you have a total of 3 items and you want to choose 3 of those 3 items, that would be the example that we had here. We have A, B, C, and how many ways can I choose 3 of those 3? That's what it would look like. And if we have our calculator, which I'll get our calculator up here, on your scientific calculator, you should have a combination button on your calculator. On this particular graphing calculator, it's hidden a bit. So I think you have to go 3, and then I think you have to hit math, and we're going over here to probability. Yeah, see? There's NCR for combinations and NPR. So the first example would be NCR. So 3, choose 3. Look at that. There's one combination that you could do that. Now, if the ingredients were A, B, C, D, and E, then you would have 5, choose 3. And of course, there would be more than one combination. But let's just focus on this first example. So 3 choose 3 is equal to 1. And this is going to be very important, using the combination formula for 11.3 in your textbook here coming up. Okay, so this is going to come back in when we talk about the binomial theorem, expansion of binomials. Okay, so that's going to be important. Make sure you know where that is on your calculator. And over here, so 3 students. So if we have 3 students and I pick, or a permutation of 3 of them, I like to use the word pick here and choose over here. So this is choose. That reminds me of combination. And pick, okay, that's where order matters. Okay, you pick in order, that matters. So you go on your calculator here and we'll do 3 choose, pick, permutation, pick 3, guess what? We get 6. Okay, so that's the difference between choose and pick. That's the difference between combinations and permutations. Okay, hope that helps.